Do you
Recording.
see it fine off of Miller's or do we need mine too?
I think we can
I
see
think
it
we're okay
fine.
with
Okay,
Miller's.
that's what
I
I,
think that's what I got from.
Okay. Let me move this all the way up to the corner. Okay.
Oh, that's Macy.
oh, yeah. Okay,
Just clap. Cool.
okay. This is our oral presentation on the results from our algal bloom study. I'm Macy.
Sadie.
And I'm Miller. Oh, I should have pressed the thing.
To start with, I have an overview of our presentation in which we will cover the background, hypothesis, experimental approach, results, spectroscopy analysis, our t-test results, our summary statement, and finally, the impact of our findings. But to start with, our objective was to test the effect of nutrient concentration on algal growth. For our background, I just have that algae is naturally found in aquatic systems. So not all algae is harmful because it is the bottom of the food pyramid or the food chain or food pyramid in ponds and lakes. So it provides food for whatever organisms are on the step above it. However, the algae that is toxic, the harmful algal blooms or HABs, it is thought to have possible causes of longer summer growing seasons, warmer water temperatures, or increased fertilizer runoff. And they can cause illnesses in people and animals, potentially fatal depending on how toxic they are and what types of toxins. They are usually found suspended within the water, like on the surface or in columns that float off the top. They don't grow out of the ground. And they can occur anywhere where there's water and appropriate environmental conditions.
So the hypothesis for our experiment was if the nutrient concentration is increased by 30%, then the algal growth should increase. So our experimental approach to our design was that it would be conducted in 3 weeks total. And during that time, we would use an instrument called a spectrophotometer to measure the absorbance of red light through the liquid culture as an estimate of the algal bloom density. So the results of our study in figure 1, it shows the red light absorbance that was collected through the class data. And for us, this was the 30% concentration. You can see that the time measurement for each of the points that we took our experiment to test and not the calculated absorbances.
Next is our spectroscopy analysis. In figure 1, you can see our little graph that we made in our results. You see all 4 test tubes. And then each categories that we have is the volume of the sodium carbonate in microliters, the volume of the PNP in microliters, the molarity of the PNP, our absorbance numbers, our extinction coefficients, our trendline coefficient, and our percent error, which, as you can also see, are all below 5%, except for tube 3, which was at 5%, which means our micropipetting was very accurate. In figure 2, we see the graph of our absorbance with the trend line and error bars for each day over this experiment that we measured the absorbance of light. Next is the results of our t-test. So on the figure 1 is day 0, or the first day that we actually took any measurements. The second figure is the 10th day, and the third figure is the 14th day. To start, we can see that we have our variances, and they're similar for both rows, but each consecutive figure they're getting bigger and bigger, and that's because we had more growth in algae. And then we also have p-values, which are all close together in value and still really small, which leads us to believe that our data collection was pretty accurate. Finally is our summary statements and impact of our findings. So for our summary, we don't have sufficient evidence to accept our hypothesis. Some data showed that we had increased absorbance, while others didn't really, and that's chalked up to the human error. That all being said, it was clear that some of our data showed great absorbance and of red light and others didn't. And then the impact of our findings is that we now know that when there's a 30% nutrient concentration added to a specific amount of algae, it increases the growth significantly and therefore it absorbs more light. Thank you. Yeah, we're done.
That was that was so much better. Stop sharing. Stop.